Okay, today we're going to practice analyzing a heating and cooling graph by completing a worksheet. But before we look at any of the questions, I want you guys to mark up your graph so that it'll make your answering your questions a little bit easier if you go through and mark up your graph. So that's what we're going to do first. So you know that the slanted line, that these lines are the state of matter. So go ahead and label it. So this is the solid, then you have your liquid, and then the gas. So then we're going to go behind it and we're going to now label this change of matter. So we can all agree that as we increase the temperature, our solid is going to change into a liquid, and then our liquid, as we increase the temperature, is going to change into a gas. So whenever we add heat, we're going to go this way, and this is called melting. When we continue to add heat, that's this line, our liquid is going to boil into a gas. Now whenever we read this graph the opposite way, starting over here and reading this way, it's a melting curve, or freezing, or cooling. It's a cooling curve, I'm sorry. So when we started a gas when it changes into a liquid, that's called condensation. And then whenever we have our liquid, it's going to freeze. This isn't really cooperating. It's going to freeze into a solid. So now that we have all of this filled out, now we're going to start looking at our questions. So the first question is, what does this graph display? It displays the heating and cooling curve. So what that tells us is how energy helps things to change the state. So it shows us how to change states of matter. So changes in states of matter. Next, whenever we're reading this graph on the time axis from left to right, how does the temperature respond, or the time? Well, it increases. Next question is, when you go from the bottom of the graph to the top, how does temperature respond? Well, temperature also increases. I'm going to take the graphs, scroll around a little bit. So number 4 asks if we have the top one. Let me see if I can grab that. I'm going to add it. Oh, this is working. Scroll down. There we go. So since we went ahead and we filled this out already, it'll be very easy to answer these questions. So number 4 is asking what state of matter is present between line segment AB. Well, AB over here is a solid. That does not look good at all. Erase that. Solid. And how would you describe the arrangement of atoms in that state of matter? Well, we know that they're very tightly compact and they have very low energy. The next question now, it's asking us about line segment CD. If we go over to our graph, This is line segment CD, has a little bit of energy, and that state of matter is a liquid. That looks horrible. How would you describe the arrangement of atoms in this state of matter? Well, they are loosely packed together and they have some energy. Finally, number 6, what state of matter is represented with line segment EF? That's right here on the graph. Right over here. So what state of matter do we have? Well, that is a gas. How would you describe the arrangement of particles? They are very, very, very far apart and they have high amounts of energy. Number 7 asks what state of matter or what change of state is represented going from B, it's over here, to C. So we have a solid that is changing into a liquid. How does it do that? Well, it does so through melting. Sure. What change of state is represented from C over here to B? Well, that would be freezing. Number 9 says what change of state is represented going to D to E? Well, that is boiling. And then what is change of state is going from E to D? Well, that's whenever a gas condenses. And that's it for this worksheet. Flip it over, go to the back. We're going to do the same thing, which is before we look at the question, we're going to mark up our graph with things that we know. We're going to do a little brain dump. So on the slanted line, recall that those slants are the state of matter. So here we have our solid, and here we have our liquid. And then finally we have our gas over here. Then we're going to label the graph. Whenever we're going from left to right, as temperature is progressing, we can see that the temperature is increasing as time increases. So we're going to do the heating curve first. So when we have our solid, it's going to change. I'm sorry, I should make it red. It's going to change, and that is called melting. Whenever we have a liquid, the liquid is then going to change into a gas, and that is called boiling. It's also evaporation and vaporization. So now we're going to read our graph from the left, or I'm sorry, from the right to the left, and as we go from right to left, we can see the temperature is going down. The temperature is going down, so this is a cooling curve. So our gas, when it changes into a liquid, that is called condensation. And then it continues down to a liquid, and then whenever it turns into a solid, that's called freezing. Now let's look at the questions. The question is asking at what temperature does the substance melt? So we want to find the part on the graph where it's a plateau. This is melting. So what at temperature does the substance melt? Well, that's 0 degrees Celsius. The next question is asking at what temperature does the substance evaporate or boil? So it boils at this temperature. So what temperature is this? 100 degrees Celsius. Number 13 asks, at what temperature does the substance condense? Find condensation up here, or condensing. That's here. And it is also 100 degrees Celsius. Make sure you put your units. The next question asking, at what temperature does the substance freeze? Well, you look up on the graph. Here is where a liquid freezes into a solid. So the temperature is 0 degrees Celsius. Number 15, what is the state of matter at 50 degrees? So go up to your temperature, find 50 degrees. What is 50 degrees? Well, your substance is a liquid. Next question asks, at what state of matter is the substance at 110 degrees? Find 110 up on your graph. Right here, go over. What state do you have? You have a gas. Next one, what do you have the state of matter at negative 10 degrees? That's here. And it meets the graph right here. So you have a solid. Number 18, identify this substance using this chart as an example of a physical property, because no matter if the substance is in its solid, liquid, or gaseous phase, it is still the same substance. It's just changing the physical appearance. Why are changes in the state of matter flat on the curve? That's regarding these up here where it says flat. Well, the reason why it's flat on these two positions is because it takes time for your substance to transition. It takes time for those particles to either speed up or to slow down. So, So it takes time for those particles to either speed up or to slow down. I hope I answered any of your questions that you had, and have a good day.